All right, good morning. We're going to be doing section 4 today. We do this one, well, if we have time, we can finish up the rest of the chapter because this is the most difficult one of all of them. This one section here, because everything we're going to cover today, after this one, you should be able to find the x-intercepts of any polynomial, any size, doesn't matter what kind. So that's what we're going to do with this one. So now we're going to look at coefficients that are either real, which are radicals and everything like that. Integers is what we've been dealing with, numbers. They could be rational, they could be fractions, or they could be complex, having eyes. And that's what we're going to look at to see if our solutions will have imaginaries and radicals and rationals and everything like that. We'll begin with talking about the fundamental theorem of algebra. What this study says is every polynomial, I don't care what size, of degree n, where n is greater than or equal to 1, will have at least one solution. And remember, a 0 is a solution. A solution is also an x-intercept, it's a factor. A set of complex numbers. Why a set of complex numbers? Because complex numbers look like this, where a and b can be positive, negatives, or zeros. So this is a complex number. This is a complex number. That is a complex number. So it could be in any form. So that's what I'm saying. Complex numbers can have any one of these three forms. An integer, a number with an I, or a combination of the two. So there's given several numbers. So we'll start backwards. If I give you the answers, can you tell me the question it came from? That's what this first part's talking about. It's Saturday. So in chapter 2, when we talked about factoring, I gave you this equation. Actually, when we talk about distributivity and foiling and things like that. And if we set them equal to 0, we could find the x-intercepts. We could, if it's set equal to 0, what are the answers? 0. No. If we set these equal to 0, then we have to set both of these equations equal to 0. So x is equal to -2 and x equals to -3. So if I had this, then you can tell me what the x-intercepts are. What we're going to do here is, if I give you the x-intercepts, can you tell me the polynomial it came from? Let's see. This polynomial, we started like this. We factored it out. We set both factors equal to 0, and then we solve for the answers. This is the way we've been doing all along. I start off with a polynomial, and you give me the answer. Now we're going to go backwards. If I give you the answers, if I give you the x-intercepts, can you tell me the polynomial it came from? Yeah, just by following this process in reverse. If I said your x-intercepts were 4 and -3, what's the polynomial that has those as the answers? Well, we set x equal to 4 and -3. We set these equations equal to 0. since both of these equal to 0, if I multiply them together, it should still equal 0. Now, if I multiply everything in this first parenthesis to everything in the second, so x times x is x squared, positive and positive is positive, x times 3 is 3x, negative times positive is negative, 4 times x is 4x, negative times positive is negative, 4 times 3 is 12. Again, this should be nothing new. We did this 2 chapters ago, and you should have done this as the homework assignments and taken the test on it. So this is the polynomial that has x equals 4 and negative 3 as solutions. So that's what we're going to do. In this first part, I'm going to give you the answers. You're going to tell me where they came from. Okay, example 1. Find the polynomial function of degree 3 having zeros of 1, 3i, and negative 3i. Example 1 from your sheet. Find the polynomial function of degree 3 with zeros at 1, 3i, negative 3i. That's what the question says. Again, everything in here is telling us something important. I mean, you don't have to write this down because you have it on your sheet also. But yeah, we're going to just abbreviate it. We know it's going to be a polynomial. What does degree 3 tell us? What does it mean?
Like x equals 3.
Nope. What is a degree in a polynomial? Again, that's what we covered last week and the week before. The degree is the highest exponent in an equation tells us the shape of the curve and it tells us the number of solutions or the number of x-intercepts. Man, it's very important. I can't tell you how important. Since we only meet once a week, it's very important that whatever we cover on the class, you have to look over that during the week. I mean, because this stuff has to, because we're going to pick up the pace pretty quick. We only have 5 weeks left. And so we got chapter 5 to do, a little bit of chapter 6 and the rest of this one. So we have a lot of stuff. We're going to pick up the pace after this lecture. So what this thing tells us is we're going to have 3 x-intercepts, 3 solutions. They are these. So we know that x equals 1, x equals 3i, and x equals negative 3i. So we're setting up our equation. So this is the first step. Since these are the x-intercepts, set them as equal to x. Second, make them equal to 0. So in this first one, we subtract 1 from both sides. So we have x minus 1 equals 0. We subtract 3i from both sides. So we have x minus 3i equals 0. And we add 3i. So we have x plus 3i equals 0. All these disappear. Again, it's degree 3, so we have to have 3 equations. Now, since they're all equal to 0, we could multiply them all together, and they're still going to equal 0. Remember, we're looking for the polynomial. So right now, our polynomial looks like this. Our polynomial looks like that, those 3 pieces. So what we have to do now is multiply them. Start with these 2, because they're both imaginary. And we discussed imaginaries 2 chapters ago. So I'll leave this one alone. What's going to happen here is when we foil these together, again, these are special, this has a special name because the terms are the same, only thing different are the signs. But if you don't remember all those rules, then we just do it the long way. X times x will give us x squared. Positive is negative is negative. X times 3i is 3ix. Positive times positive. 3i times x is 3ix. Positive times negative is negative. 3i times 3i. 3 times 3 is 9. I times I is I squared. So leave the first one alone. Now combine like terms in the second one. We have negative 3ix, positive, so these cancel. So we have x squared minus 9i squared. What does I squared equal? Remember, I is equal whenever you have a negative inside a square root. So when you square it, you get a negative 1. So all of this really does is change the sign of the number in front of it. Because negative 9 times negative 1 is going to be a positive 9. Notice there's no more i's. Now we got to multiply these 2 together. X times x squared is x cubed. Positive times positive is positive. X times 9 is 9x. Negative times positive is negative. 1 times x squared is x squared. Negative times positive is negative. 1 times 9 is 9. Let's rearrange those. So we have x cubed, negative x squared, positive 9x, minus 9. And there's the polynomial that we're looking for. The question can also give you, let's review what a multiplicity is. The multiplicity is the number of times the same zero occurs. So then how do we know where it is? It's the exponent of the factored binomial in the parentheses. It's the exponent. It's that n up there. So for our last example, when we factored them out, we had this. The multiplicity of each of these were 1. Because if you add the multiplicities, you get the degree. It tells us something else also. The multiplicity also tells us if the graph crosses or bounces off the x-axis at that point, at that intercept. So let's pretend we have this polynomial. The degree is 2 plus 1 plus 4 plus 3 is 10. And if you reviewed your notes, the degree of 10, if the degree is even, that means both ends point the same direction, either up or they both point down. Since all the coefficients are positive, our graph at both ends will point up. Again, this is why it's important that you stay current with what we're talking about. You have to review the notes. -5, -1, -3, -5. Our zeros are going to be at +2. That one's at +2. This one's at +4. This one's at -3. This one's at -5. We set all those equal to 0. Again, it's important to stay current with your notes. So those are our 4 intercepts. We know at both ends the graph goes up. At -5, it's an odd exponent, which means it crosses. If the multiplicity is odd, it crosses the x-axis. If the multiplicity is even, it bounces off the x-axis. At -3, the multiplicity is 4. So we know it's going to come over here. It's going to bounce off that one. At 2, it's even also. So it's going to bounce off that one also. And at 5, it's 3. So it's going to cross. And of course, it'll have different shape, but that's basically what it's going to look like. Again, the multiplicity of everything, that was a section 3. So if you review those notes, you'll have a better understanding of what's going on here. So what if I give you like example 2? Example 2 says, find a polynomial function of degree 5. So find a polynomial function of degree 5 having the 0 with zeros 1. No, with -1 is a 0, so it's -1 with multiplicity 3. Multiplicity of 3. 4 as a 0. 4 with a 0 of multiplicity 1. And 0 as a 0 of multiplicity 0 as a 0 with multiplicity 1. That's all it tells us. So we have a polynomial P of X of degree 5. Again, 5 tells us the number of answers we're supposed to have. And if we add up our multiplicities, 3 plus 1 plus 1, we get 5. That's a good check. So we're supposed to find a polynomial. The polynomials have our zeros at x equals -1, at x equals 4, and at x equals 0. That's what these tell us. Okay, so that's the first step. Now we have to set all these equal to 0. So we add 1 here. X plus 1 equals 0. Subtract 4. And leave that one alone. So we have those 3. Now we take each one of those. Everything that equals 0, take each of these, and those are your polynomials. If you move around, the light will come back on. If you have to stand up or something, is there. So now we look at the multiplicities. -1, which is the first one, has a multiplicity 3. This one has 1, and this one has 1. So with that, we can look at a basic graph of this thing. because we have zeros at -1, at 4, and at 0. The degree is 5. From last section, if the degree is 5, we know that means the ends point opposite directions. Either they both, this one goes down, goes up, or this one goes up, this one goes down. Again, that's last section. Since all your coefficients are positive, the right side goes up. It's an increasing function. So we know that our graph will look something like this. At the endpoints, the right side goes up, the left side goes down. At -1, it's an odd exponent, so it crosses. At 0, multiplicity is 1, so it also crosses. At 4, the multiplicity is 1, so it crosses again. So there's our graph. Again, review section 2 for what all this stuff means. So what we have to do, we have to find the polynomial. X plus 1 to the third means x plus 1 times x plus 1 times x plus 1 times x minus 4 times x. But we just have to start multiplying them. Left, since there's no imaginaries, we just keep on going just straight across. So this first one, x times x is x squared. X times 1 is positive x, positive x, positive 1. And just bring the other one straight down. Combine like terms, so we have x squared plus 2x plus 1. Now we multiply these two. X squared times x is x cubed. X squared times 1 is x squared. 2x times x is 2x squared. 2x times 1 is 2x. Since all the signs are positive, they're all going to be positive. 1 times x is x. 1 times 1 is 1. And just bring down what's left. Combine like terms, we have x cubed. We have these two x squareds, 2 plus 1 is 3x squared. 2 plus 1 is 3x plus 1. Do it again. Multiply these two together. X cubed times x is x to the 4th. Positives and negative is negative. X cubed times 4 is 4x cubed. X squared times x is 3x cubed. Positive times negative is negative. 3 times 4 is 12x squared. 3 times x, it's a positive, 3x squared. Positive times negative is negative. 3 times 4 is 12x. Positive, positive is positive. 1 times x is x. Positive times negative is negative. 1 times 4 is 4. And bring down the x at the very end. Combine like terms. We have x to the 4th. Negative 4 plus 3, since 4 is bigger, the answer is negative. 4 minus 3 is 1, x cubed. Negative 12 plus 3, 12 is bigger, it's negative. 12 minus 3 is 9. Negative 12 plus 1, 12 is negative, so the answer is negative. 12 minus 1 is 11 times x. Now just multiply x to everybody, but that's what this again says. So we have x to the 4th times x is x to the 5th. A minus x to the 3rd times x is x to the 4th. Minus 9x squared times x is x cubed. Minus 11. X times x is x squared. Minus 4 times x is 4x. And here's your polynomial. So again, it's the same step. Only thing with this one did is it showed you with multiplicities what your beginning one would look like. I would first put that in there in the answer to see if it'll take it. If it'll take it, you're done. If not, then I want you to do all this. But so I would first try enter this in the computer in the homework. Okay. Now, those are all integers. There are 2 rules you have to know. If you have imaginary or radical terms in your polynomial, then you have to know this. Imaginary and radical solutions or zeros always occur in conjugate pairs. This is important. What are conjugate pairs? Conjugate pairs we talked about when we did the beginning part of this chapter. If you had A plus BI, then you also have to have an A minus BI. Conjugate pairs just has a different sign in front of that term, in front of the I term. If you had A plus radical B, then you have to have an A minus radical B. It just changes the sign in front of those terms. And we saw one of those already, actually, in example 1. Example 1 says you have your zeros are 3i. Because this one's 3i, you have to have a negative 3i also. If you have an answer that's an imaginary or a radical, you have to have the conjugate of it also. why do we have conjugate pairs? What's the conjugate pair to that one?
3 minus
Right. And same with this one. It would be 3 minus radical 2. Let's work these out. So we see we have imaginaries and radicals in our problem. If we multiply these out, we got 3 times 3 is 9. Positive times negative is negative. 3 times 2 is 6i. Positive times positive is positive. 2 times 3 is 6i. Positive times negative is negative. 2 times 2 is 4. I times I is I squared. Combine like terms. Negative 6i positive cancel. I squared changes the sign of the term in front of it. So it changes it so you don't have any more imaginaries if we multiply them all out. Likewise with the radicals. 3 times 3 is 9. Positive times negative is negative. 3 times radical 2 is 3 radical 2. Positive times positive is positive. 3 times radical 2 is radical 2. Positive times negative is negative. Radical 2 times radical 2 is what? It's radical 2 squared, but those cancel. So it's always, if you have the same number, radical A times radical A will always be A. So no matter what's inside there, it'll just be the same thing. Combine like terms. These cancel. So we have 9 minus 2 is 7. Again, same thing. We get rid of the radical in that term. So far, so good. Let's look at example 3. Example 3 says, suppose that a polynomial function of degree 6 with rational coefficients negative 2 plus 5i, negative 2i, and 1 minus radical 3 as 3 of the zeros. Find the other zeros. So find the other zeros of degree 6 with the zeros negative 2 plus 5i, negative 2i, 1 minus. So what this thing says, these are my zeros. So these are the x-intercepts. Yeah. Yeah, stand up. So it's degree 6, which tells us what? No, we have 6 solutions. We only have 3 solutions here. So we're missing 3 more. What are the other 3? We're missing 3 more. What are they?
Oh, it's -2 minus 5i,
Very good.
+2i.
Very good.
Those groups which assigned to the radicals.
Mm-hmm.
So 1 + 3 squared.
3 radicals. Radical 3, right. Right, and those are the conjugate pairs. Those are your 6 intercepts. So what would the polynomial look like? So for all of these, we have to set them equal to 0. So we'd have x plus 2 minus 5i equals 0. I move each one of those over. X plus 2i equals 0. Whenever you move something from one side to the other side of the equal sign, it changes signs. That's all I'm doing. This is a -2. When it goes over here, it becomes a +2. This is a -2i. Come over here, it comes a +2i. So whenever you move it to the other side, it just changes signs. So 2i plus 5i equals 0. X minus 2i equals 0. X minus 1 minus radical 3 equals 0. So your polynomial would be all of these multiplied together. Whatever equals 0. So x plus 2 minus 5i times its conjugate, x plus 2 minus 5i, x plus 2i, x minus 2i, x minus 1 plus radical 3, x minus 1 minus radical 3. 1, 2, 3, 4, 5, 6. We have 6 intercepts. And it doesn't ask, it just says, this question just asks to find the other 3, and those are your answers. Yeah, these would be the answers. That's what you would type in the calculator, computer. Okay, let's look at example 4. This one's going to have us work it out. It says, find the polynomial function of lowest degree with rational coefficients. Find the polynomial. So how do I do it? What do I do with these two? I have to set them equal to x first. Now you set them equal to 0. Because if you just set these equal to 0, it's not going to do anything. Because there's no x's anywhere there. Now you set them equal to 0. So what's going to be the degree of your final answer? No. polynomial will have a degree 4. Anytime you have a radical or imaginary, you have to find the conjugate pair. These are not conjugate pairs, so we have to have another one that looks like this. It's just change the sign in front of the radical or the I. So your polynomial will be degree x plus radical 3, x minus radical 3. That's 2 so far. X minus 1 minus I, x minus 1 plus I. 1, 2, 3, 4. We have 4 solutions, so it's degree 4. Again, first, I would just plug in those as the answers to see if they will work or how do we want it. If it doesn't, then we have to multiply them. We'll multiply these two separately. X times x is x squared minus x radical 3 plus x radical 3 minus radical 3 squared. That's the first one. The second one's going to be a lot longer. X times x is x squared. X times negative 1 is negative x. X times positive I is xi. Negative 1 times x is negative x. Negative 1 is positive 1. Negative 1 positive I is negative I. Negative I times x is negative xi. Negative I, negative 1 is positive I. Negative I, positive I is negative I squared. Again, don't bobblehead. Try to do it yourself first and then check your answer, because I need to see what you know. Because all you're doing now is you're doing great as a Xerox. So what do you do next? Combine, no, you have to first combine like terms inside there.
So, what we do for the first one is negative x3 and the x plus 3 radical.
These cancel.
And for the negative 3 radical squared, wouldn't that just be a 3?
3, right. So those cancel, right. So start with the highest power. So x squared is there. There's nothing else. You have a negative x makes it negative 2x. Positive xi, negative xi cancel. Negative I, positive I cancel. So you have a plus 1. And the I squared is the same thing as negative 1. So you have a negative 1 makes it a positive 1. That's what I'm saying. I need to see what you know, because when you do this by yourself, I'm not going to be around to help you. So be very careful about the signs. I squared is negative 1. Negative makes it a positive 1. So this becomes x squared minus 3. X squared minus 2x plus 2. And then continue. You're not gonna see what I do till I unfreeze it. I wanna see what you get first. That was a pretty tough one. Good. Excellent. Good job. Now, so far so good. So if we have radicals or imaginaries, we always have to have conjugate pairs. Now let's look at this. Remember, what are rational numbers?
One,
Exactly. Rational numbers are fractions. Like 1/3, or -5/7, or 4, or -2. Those are all rational numbers. Oh, I'm sorry. I'm sorry, yeah. Right, so the answer was that for the last question. Very good. Okay, exactly what you got. All right, so rational numbers. Rational means fractions, but all of these are fractions. 4 is the same thing as 4/1, -2/1. So fractions can be like this we're used to, or they could be integers. That's what we're going to look at now. We're going to look at the rational zeros theorem. What this one says is let P of X be any polynomial of degree n that's any polynomial. And let the zeros of P of X be represented by P over Q, a rational number. Where P and Q are relative prime numbers. So in your equation, P is represented by the last number, the constant, and Q is the leading coefficient. Is the constant term, and Q is the leading coefficient. Then we could find the zeros this way. So, for example, let's look at something we've already done. Let's pretend our polynomial f of x is made up of x squared plus 5x plus 6. So we're trying to find p over q. P is what? It's just a 6, yeah. And q is the 1. Because what we're looking at here, these are going to be the zeros. In other words, we don't know yet if they're going to be positive or negative. So each one of these is going to be positive or negative. So what we're going to do here is what are the different combinations that make up 6? What makes up 6? What times what equals 6? One times 6. That's 6 times one times the same thing.
3/2.
And that's it, right? So the top number can be any one of these numbers. The bottom is going to be 1. So let's look at each one of these separately. So you have 1 over 1 plus or minus 2 over 1, 3 over 1, and 6 over 1. So the rational zeros theorem tells us that our answers, 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and 6 over 1 is 6. Our answers will come from here. And remember, we're only going to have 2 answers. So with this whole process, the rational zeros theorem, what it does is, without this, we have an infinite number of numbers to try to factor this out. Because what we're going to do now is use synthetic division. And again, we did that last section. Synthetic division, because we're going to try to find zeros. And if we find a 0, then it's going to be, if the answer is 0 when we do synthetic division, that means that's a factor. That's a solution. So here's our polynomial. These are our numbers. We're going to try with 1 first. We're going to try with positive 1 and 1. Positive 1, negative 1 first. So remember synthetic division? We're going to try with positive 1 and negative 1 first. Inside here goes the coefficients of x squared, of x, and the constant. So it's going to be 1, 5, and 6. 1, 5, and 6. The process of doing synthetic division is bring the first number down and multiply. 1 times 1 equals 1. Add straight down. 5 plus 1 is 6. Repeat the process. 1 times 6 is 6. Add these straight down, you get 12. It's not 0, so that's not a 0. 1 doesn't work. Let's try the next one, negative 1. So negative 1 times 1 equals negative 1. 5 minus 1 is 4. Negative 1 times 4 is negative 4. 6 minus 4 is 2. So negative 1 is not a solution. So our next number is 2. We have 1, 5, 6. Bring the first one down. Multiply. 2 times 1 is 2. 5, add these straight down. 5 plus 2 is 7. 2 times 7 is 14. 20. So 2 is not a solution. So we try -2 with 1, 5, and 6. -2 times 1 equals -2. 5 minus 2 is 3. -2 times 3 is -6. And we get a 0. So that means x equals -2 is a 0. Now, once we find a 0, we're done with this one. We just have to look at what's out here. Since there's only 2 terms left, this is a constant and this is the x. So this one says that x plus 3 is a factor. So that's a 0. In other words, our next one would have been at -3. So since we found our zeros, -2 and -3, we know the factor. If x equals -3 is the answer, then x plus 3 is the factor. If x equals -2 is the answer, then x plus 2 equals 0. These are the factors. So there's a lot of things we can tell with that. All right. So let's look at a bigger one now. Let's look at example 5. Here's our polynomial. F of x equals 3x to the 4th minus 11x cubed plus 10x minus 4. So A says find the zeros and then find the factors. It's number 5 says, given this polynomial, find the rational zeros and then the other zeros. That is, solve for f of x equals 0. Let's solve the zeros. And then once you find the zeros, find the linear factors. Or just put them in parentheses. So to do this, we have to take P over Q. And only the numbers, because the plus or minus takes care of any signs. So on top we have 4, on the bottom we have 3. So what is 4 made up of? Yeah, so it's 1, 2, or 4. What's 3 made up of? Very good. So with this equation here, we have an infinite number of numbers we can choose from. But what this does, it narrows down to 3 times 2, 6 times these two. But so it narrows down infinitely down to 12 possible answers. There's 3 on top times 2 is 6 times 2 possibilities. So it's 12 answers. And all we have to do is find 4 of them. Every time we find one, we get easier and easier. So our numbers are 1 over 1, 2 over 1, 4 over 1, 1 over 3, 2/3. And then 4/3. So these are the numbers that we're going to be looking at. So these are the ones we have to try. The first one, we're going to start out with +1. Let me try to do this in two. So our polynomial starts off with x to the 4th, x cubed, x squared, x, and a constant. So only the coefficients. 3, -11. Nope, there's no x squared, so it's 0, 10, -4. Notice there's no x squared in the equation, so we put a 0 there. Bring the first term down and multiply, add, multiply, add. 1 times 3 is 3, and add straight down. -11 plus 3, -11 minus 3 is 8. Now multiply. 1 times -8 is -8. 0 minus 8 is -8. 1 times -8 is -8. 10 minus 8 is 2. 1 times 2 is 2. -4 plus 2 is -2. So 1 is not an answer. Then we do -1. 3, -11, 0, 10, -4. Bring the first term down. Multiply and add. -1 times 3 is -3. -11 minus 3 is -14. -1 times -14 is +14. 0 plus 14 is 14. -1 times 14 is -14. -14 plus 10 is -4. -1 times -4 is +4. Then you go 0. So x equals -1 is a solution. How many more do we need? What's the degree? The degree is 4. The degree is the largest exponent of the x's. That tells us we have 4 solutions. We just found 1. We have 3 more to go. Okay, once we find a 0, we're done with this top one. All we have to do now is look at these. Three, -14, 14, -4. Here's a good rule to get into. There could be multiple -1 as solutions. So whatever your last number that was a 0, try it again, see if it works again. Because we know 1 doesn't work. Let's see if -1 works twice. Bring the 3 down. -1 times 3 is -3. -14 minus 3. They're both negative, so we add them. -1 times -17 is 17. It's 31. Times -1 is -31. -35. So no, that one doesn't work. So I'm done with the ones. Now I do twos. I look at +2. 3, -14, 14, -4. Two times 3 is 6. -14 plus 6, 14 is bigger, so it's negative. 14 minus 6 is 8. 2 times -8 is -16. 14 minus 6, 16 bigger, so it's -16 minus 14 is 2. 2 times -2 is -4, makes it -8. So no, 2 is not it. So we do -2. So we try -2. 3, 14, 14, 4. These two are negative, I believe. Multiply, -2 times 3 is -6. -6, -14 is -20. Negative is positive. 2 times 20 is 40. Okay, that's going the wrong direction. So we know it's not going to work. So the next number we try is 4 and -4. Three, -14, 14, -4. Four times 3 is 12. -14 is bigger. 14 minus 12 is -2. 4 times -2 is -8. 14 minus 8 is 6. 6 times 4 is 24. So the answer is 20. So no, 4 doesn't work. Let's try -4. Put the first one down. -4 times 3 is -12. Negative is negative. 12 plus 14 is 26. Negative is positive. 4 times 26 is 104. No, that's just going the wrong direction. I know that's not going to work. So the next number we're going to try is 1/3. Three, -14, 14, -4. Bring down the first one. 1/3 times 3 is 1. 1/3 times 3. The 3's cancel, so it's just 1. -14 plus 1 is -13. 1/3 times -13 is -13/3. And we see that's not going to work because now we're going to have fractions from here on out. Because we'd have to get a common denominator. So this would be 42/3 minus 13 would be 29/3 times 1/3. It just get much bigger. So it's not going to work. So we try -1/3. Bring down the first term. So -1/3 times 3. 3's cancel, so it's -1. -14 minus 1 is -15. Negative and negative is a positive. 15 divided by 3 is 5. 14 plus 5 is 19. So it's -119/3. So -1/3 times 19/1 is -19/3. And that's not going to work because that's not going to equal 19. So that one doesn't work. So we try 2/3. I believe it's 2/3, isn't it? Yeah, 2/3. Three, -14, 14, -4. Bring down the first term. 2/3 times 3, the 3's cancel. We'll just get 2. -14 plus 2 is going to be -12. 12 divided by 3 is 4. So -4 times 2 is -8. 14 minus 8 is 6. 6 divided by 3 is 2. 2 times 2 is 4. So here's our second one. X equals 2/3. That's another 0. Now we're done with that one. We just have to look at this. But once we get to this stage in trinomials, because this is a constant, this is x, and this is x squared. So what we have now is 3x squared minus 12x plus 6. Once we get the quadratic equations, we can stop doing the synthetic division. We can either factor this or we can use the quadratic formula. So with this one, they each are a factor of 3. So we take out a 3. Or it's divide each, once I take it out, divide by 3. So it's be -4x plus 2. Label A, B, and C. A, B, C. A is what's in front of the x squared, 1. -4, 2. And we're going to plug them into the quadratic formula. So negative b. B is -4, so it's negative of a -4. -4 squared minus 4 times a times c. A is 1. I'm going to just work it out. Negative and negative makes it a +4, plus or minus. 4 squared is 16. Negative, positive, positive is a negative. 4 times 1 is 4 times 2 is 8 over 2. (16 minus 8 is 8. So radical 8, we can simplify that. Radical 8. 8 is made up of 2 times 2 times 2. It's 4 times 2 is 4. So since there's 2 of a kind, we could bring that out in front. So 8 can be written as 2 radical 2. 2 radical 2 over 2. We have a common denominator, so we have 4 over 2 plus or minus 2 radical 2 over 2. Four divided by 2 is 2, and the 2's cancel. Those are your next two answers. The two answers are going to be x equals 2 plus radical 2, x equals 2 minus radical 2. So here are our four answers. And the first one was -1. So that's only part A, finding the zeros, the x values. Part B says factor into linear factors. So part B so let's take example 5, part B. So now we have to take each one of these. And set them all equal to 0. So we have to move everything over to the other side. So x minus 2 minus radical 2 equals 0. X minus 2 plus radical 2 equals 0. There's another one. This one here is tricky because there's two ways you can do it. One, you could just move it over like that. And this last one is going to be x plus 1 equals 0. So your polynomial is made up of these zeros. Those are the linear factors. There is only one thing we can change here to make it look nicer. That's this one here. X minus a fraction doesn't look good. If you have something like this, X equals 2/3. The way we've always done it in class, whenever you have a variable with an equal sign and a fraction, get rid of the fraction first. So multiply both sides by the LCD. So we have 3x equals 2. And then move the 2 over. So this one, if we put 3x minus 2, it looks cleaner. But I think it'll take both of them though. But that's the answer. So let's look at example 6. Example 6 says, given the polynomial 2x to the 5th minus x to the 4th minus 4x cubed plus 2x squared minus 30x plus 15, find the same things. Find the zeros and then find the linear factors. Two x to the 5th minus x to the 4th minus 4x cubed, 2x squared, 30x plus 15. So what's our first step? Right. What's P? And Q? Then what do we do with that?
You have to find the difference.
Multiples.
Yeah.
Right. So what makes it 15?
1, 15, 3, 5.
That's it. So it's 1, 3, 5, 15. And the bottom is pretty straightforward. 1 and 2. So we have 4 on top, 2 on the bottom. So 4 times 2, we're going to have 8 times 2. There's going to be 16 totals we may have to check. So it's going to be 1 over 1, 3 over 1. I know all of these have to have a plus or minus. So I'm not going to put plus or minus in front of each one. 5 over 1, 15 over 1, 1 over 2, 3 over 2, 5 over 2, 15 over 2. And they're all plus or minuses. So we only have to check 1, 3, 5, 15, 1/2, 3/2, 5/2, and 15/2. Now comes the long part. So let's look at 1, -1. So we have 1, x to the 5th, x to the 4th, x to the 3rd, x squared, x, and a constant. So 2, -1, -4, 2, -30, 15. How many answers are we going to have? Mm-hmm. What is it? Mm-hmm. It's the biggest exponent. That's the degree. We'll have 5 answers. So let's start with the first one. One times 2 is 2, minus 1, 1 is 1, minus 4 is -3, 16, so one's not right. Let's try -1. 2, -1, -4, 2, -30, 15. Add those straight down. 3, so -1. 3. Yeah, so just keep on going until you find a 0. What number are you on now?
2.
Oh, you is it fire already? Good. Yes, nothing works yet.
No.
Okay, yeah. So far, so good. Yeah, like you, on 15, you see the first number is 2, then 29. It's just gonna explode even further, so I don't have to waste my time with it. It's gonna get bigger and bigger and bigger.
Yeah.
Yeah, when you see it's gonna be outrageously large, don't even waste your time. Just go ahead and stop and go on to the next one. Same with -15.
Yeah, I was gonna say for 1/2, well, you just keep on multiplying it times 0.
Well, yeah, because the first one, 1/2 times 2, the 2's cancel, so it's just 1. That's 0. So 1/2 times 0 is 0. Add those. We get -4. 4 divided by 2 is 2, so it's -2. Add those 0 times that 0. So it's -30 divided by 2 is -15. But here's the beautiful part about this. Whenever you have this kind of, it has a sequence, so it's missing things. Let's see what this one looks like. That's the 0, so that's a constant. This is one of our first solutions, so that's good. This is a constant. That's the x. This is x squared. This is x cubed, and this is x to the 4th. So we have is 2x to the 4th minus 4x squared minus 30 equals 0. What we see here is we have a quadratic equation. Remember, a quadratic equation looks like this, right? So the middle term, if you take the exponent of the middle and multiply it by 2 and get the first one, then it's quadratic in form. So 2 times 2 is 4. So it's quadratic in form. We can factor out a 2. So divide each of these by 2. Remember, we still have to use the 2 in our final answer when we factor it out. So how about this one? Can we factor this one now? So again, what times what is x to the 4th? It's x squared, x squared. Second sign's a minus, so the signs are opposites. What two numbers multiply to give you 15? When you subtract them, you get 2. And the bigger number gets negative, so it's 5 here and 3 here. So now it's a lot easier because now we just have to set these two equal to 0. Subtract 3, add 5. And square root both sides. Because we found 1, we need 4 more answers, and here they're going to be. When we cancel Whenever you square root something squared, you have to put a plus or minus in front of the answer. You can't have a negative inside a square root, so that becomes an I. And those are our conjugate pairs. And we have our conjugate pairs of our radicals. So what we have right now, we have x equals 1/2, x equals positive I radical 3, x equals negative I radical 3, x equals radical 5, x equals negative radical 5. These are our 5 answers. So these are the zeros. Now, let me put the original equation down. We had 2x to the 5th minus x to the 4th minus 4x cubed plus 2x squared minus 30x plus 15. Now, what are the factors? Well, we have a 2. Remember this 2 here? That goes in front. This one, just move it over so we have x minus I radical 3. That's another one. And we have the other one, x plus I radical 3, because they have to come in conjugate pairs. X minus radical 5, that's that one. X plus radical 5, that's that one. And we can say x minus 1/2 if you want. Those are the 5 factors. Or we can say all of those. Both of these will work. Those are your factors of the polynomial. It's just that I just don't like fractions in there. So I just multiplied both of them by 2. So it's 2x minus 1.
So both the fraction and the 2x minus 1 will work in the.
They should work, yeah. I will try this one first. If it doesn't work, if it says it doesn't accept it, then just move this 2 in front of the x and you're done. But yeah, this is what you have originally. So plug it in there. If that doesn't work, this one just looks nicer. It's all cosmetic. So yeah, it's not that difficult. It's just long. But we made it shorter because if you could see a pattern, if you have every other one's a 0, then we can have this kind of setup. So this one can go there. All right. So what we've done so far is we've taken a polynomial, any size polynomial. Let me get P of X. Right now, there are an infinite number of numbers we can try to solve those. Then, using the rational zeros theorem, we found P over Q. That narrows it down from infinity to that many. But even at that, that's still too many. There's this last one. I mean, we had 1, 2, 3, 4 on top, times 2, it's 8, times 2. We have 16 possibilities we have to try. We can narrow that down even further now. The Cart's rule of signs. Because in a question like this one, we have 8 positives and 8 negatives. And not all of them are going to work. So what the Cart's rule of sign does, it tells us the maximum number of positive and negative solutions. Because if it tells us that we only have one negative and we find that negative, we don't have to try any more negatives. We're done. So this could narrow it down even further. This is done by counting the number of sign changes in your equation. So P of X, when X is positive, number of positive solutions. And if we change it to negative X, we can find the number of negative solutions. Okay, now, but number of negative solutions. Let's say we had that. And if that's this one already. So if I put a negative X in there, what I'm really doing is this. I'm putting in anywhere I see an X, I put a negative X. But the only thing that changes is if you have an odd exponent, that negative goes up front. If you have an even, it cancels that. So we just use whatever signs that in front already. So that's a negative times positive is negative. So whenever you change X to negative X, only change the sign in front of the odd powers coefficients. So let's look at example 7. Example 7 is determine number of variations of sign. So 2x to the 5th minus x squared plus x plus 4. Two x to the 5th minus 3x squared plus x plus 4. So number of positive solutions. Let's count these sign changes. All right, so this one's positive. It goes to a negative. That's one sign change. This was a negative, goes to a positive. That's a second sign change. And then positive to positive, nothing. So we only have 2 sign changes. So we have 2 possibilities. But, so we'll have at most 2 positive solutions, or we may have 0 positive solutions. Because remember, imaginaries and radicals always happen in pairs. So if you have an imaginary answer that, and they're both and it's positive, it may take care of both those. So you always, whatever number you get first, subtract by 2 until you can't do any more. Always subtract by 2 because of the conjugate pairs. So in other words, if I had 7 if there were 7 possibilities, or I can have 5, or 3, or 1. So all of these are my possibilities. So whatever you get on your first count, start from there and subtract 2 until you can't do any more. So that's the number of positives. Let's look at the number of negatives. So really what's happening is I'm putting a negative x inside there. And the only ones that change anything is if it has an odd exponent. And that just changes the sign of the coefficient. So it's negative 2x to the 5th. If that's an even, that one just stays the same, 3x squared. This one changes that to a negative plus 4. So let's count the sign changes. Let's look at the number of negative solutions. Negative to negative, that's nothing. Negative to negative, that's nothing. Negative to positive, we'll have 1 negative one for sure. So we're going to have 1 negative, at most 2 positive. What happens to the other one? We're supposed to have 5 answers. What's going to happen to the other 2? So let's see. Let's look at this. You can have positive solutions, negative solutions, or imaginary or radicals. But they have to equal this many. So we're supposed to have 5. We know we have 1 because you can't subtract 2 from there. If we have 1 of those, we can have 2 of those. That means we have to have 2 imaginaries or radicals because they have to equal 5. We have 1 of these. We can have 0 of these, which means we'll have 4 of these. And that's what it tells us. So we can have any of these combinations that are possible. Let's look at example 8. Our polynomial is 2x to the 5th minus 5x squared minus 3x plus 6. So how many positive solutions are we going to have? Why 1?
The positive, it's 2. Positive 2x goes into the negative 1.
Right?
And then it stays at until positive 6.
Beautiful. Perfect. So we'll have 2 or 0. How about negative solutions? So remember, when you have a negative in there, only change the sign in front of the odd powers. So this one and this one. So it becomes negative 2x to the fifth. Leave that one alone. And that one becomes a positive. So I only have to change the signs of those two. So how many sign changes are there now? Very good, right here. It's the same as the other one. We're supposed to have 5 answers. So the number of positives we'll have 1 negative for sure. We have 2 of those, so we have 2 of those. We have to have 1 of those for sure, and possibly none. So this is the number of outcomes that we may have. 122 or 104. Example 9. 5x to the fourth minus 3x cubed plus 7x squared 12x plus 4. How many answers are we supposed to have? Yeah, we should have 4 total, period, for all of it. So how many positives will we have? 4 or 2 or 0. And how many negatives? Well, we don't know yet. But yes, you're right, because the only signs we change are this one and this one, because even powers leave alone. So it's going to be 5x to the fourth. Change that to a positive. Change that one to a positive because the exponents are odd. They're all positive. So we have 0 negatives. We can have 4 of those. That means we have 0 of those. We can have 2 of these. That means we have 2 of those. Or we can have that we have that combination. And the last one. Example 10. The polynomial equals 6x to the sixth, 2x squared minus 5x. Number of positives? Right here. So we change it to negative x. So that doesn't change. That doesn't change. This is the only one that changes. So we have 6x to the sixth. We change that to a positive. So the number of negatives are 2 or 0. Because here's a sign change. Here's a sign change. But we're supposed to end up with 6. Positives, negatives, and everything else. So we're definitely going to have 1 positive. We can have 2 negatives. Uh-oh. There's going to be a problem. Why is this a problem?
Since it's field magic, you're supposed to be.
Conjugate pairs, right. So that means one of these is going to have a multiplicity of 2. So that means we can have 2 of the 2 positives, 2 negatives, and 2 of those. We can have 1 positive, 2 negatives, or 3 negatives, and 2 of those. That's all we can have. Oh no, we have 1 positive, actually 2 positives, none of those, and 4 of these. Yeah, there's a bunch of combinations we can do. So this is going to be a problem because of all the different combinations we can have. We know we're only going to have 1 positive, 2 or 0. And either of those will give us an odd number here. So that means we'll probably have a multiplicity of the positives. All right, that covers that section. Yeah, as I said, that's the most difficult because we start off with